Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to develop code relation matrix in MAXQDA. Code relation matrix in MAXQDA is a tool designed to explore the relationships and co-occurrence patterns between different codes. It helps researchers identify connections, overlaps, and intersections within their coded data, providing deeper insights into the interplay of themes. Code relation matrix in MaxQDA provides three distinct methods for analyzing the relationships between the codes. These methods are: first one is intersection of codes in a segment. Second, proximity of the codes in the same segment. And third one is occurrence of the codes in the same paragraph. This allows researchers to explore co-occurrences at varying levels of granularity. Let's try to understand all these three methods by one example. The youth today face many challenges. Unemployment is a major issue and it often leads to a mental stress. Many youth struggles to find jobs in their desired fields, resulting in frustration. This issue also causes an increase in social unrest, particularly in urban areas. So we start with the first method, intersection of codes in a segment. This measures how often two or more codes are applied to exact same text segment. A segment is a specific portion of the text like phrase or a sentence that is coded. So the segment is unemployment is a major issue and it often leads to mental stress. Codes are unemployment and mental stress. Both codes intersect here because the text is relevant to both concepts simultaneously. Let's try to understand this concept with the help of set theory representation. Let A, segments coded with unemployment. Let B, segments coded with mental stress. Intersection. Overlap between A and B is the set segment. So you can see overlap, same text, same segment has been coded as unemployment and coded as mental stress. This is intersection of codes in a segment. Second method, proximity of codes in same segment. This measures how close two codes are when to apply to the same segment without requiring complete overlap. The codes could apply to different parts of the same segment. Segment is unemployment is a major issue and it often leads to mental stress. Codes unemployment is coded for unemployment. Unemployment is coded for unemployment is a major issue, so this is a segment. Mental stress is coded for it often leads to mental stress. The proximity here indicates a relationship between unemployment and mental stress in the same segment, even though they do not fully overlap. So code A unemployment, code B mental stress, how much they are nearer to each other. That is the proximity between these two codes. Set theory representation, let A is unemployment is a major issue, let B it often leads to mental stress. While A and B are adjacent, proximity, they are not intersecting. So in previous case, they were intersecting. Here, they are not intersecting. Third method, occurrence of the code in the same paragraph. This measures whether the two codes appear anywhere in the same paragraph, regardless of proximity or intersection. The codes are loosely related because they occur in the same context. Now, the example, the youth today face many challenges. Unemployment is a major issue and it often leads to mental stress. Many youth struggles to find jobs in their desired fields, resulting in frustration. This issue also causes an increase in social unrest, particularly in urban areas. So the codes are unemployment and mental stress. Remember, they are in the same paragraph. So the codes are unemployment, mental stress, frustration, social unrest. All four codes occur in the same paragraph, even if they are applied to the different parts of the text. Set theory representation. Let A, B, C, D represent unemployment, mental stress, frustration, and social unrest. The paragraph is the universal set U containing all codes present in it. Now let's see how we can do this in MaxQDA. So here we are having document groups, code groups. We will go in Visual Tools and activate code relation. Now, activate all codes here, and in case of columns, activate the activated codes. So all codes in rows, activated codes in columns. So you can see the first method, intersection of codes in a segment. Click OK, and we got the result. So if I want more codes here, what I'll do, just click again here on work-life balance, click OK, and see, you will get more output. Maximize. So these are the codes for rows and columns. Now let's understand this. 33 coded segments are such in which friends and family code has been used, and this is auto code. 29 coded segments are such which are having satisfaction also and friends and family also. Now click here, double click on 29. All 29 coded segments will appear. Again, maximize it. Now we will start with this code hierarchy. Do you want, or if you don't want, then click here. Here, names column none. This will not be generated. This is for short and this is for long. Okay. The output, instead of numbers, we can generate the squares also. So this 33 is having more coded segments and it will be having the large square. Let's check. Perfect. Instead of squares, I can use circles also. I can use numbers also. Numbers with squares. Now this particular concept 1, 2 and 3 I have already discussed in my previous tutorial. Let's see how what is the use of it. 33 is the coded segment which is largest. So if I activate this, it will have a large square. So this particular option is utilized when we want to generate all other squares relative to this particular coded segment. I again repeat, when I activate this option, which is calculation of the symbol size refers to all cells, it means that first of all, it will find out the largest coded segment. It will give the large square, and all other coded segments will be based on the reference of this. There is one more option, and that is calculation of symbol size refers to the column. Now what this will do, let me activate again this part. It will identify the largest code in the column. So here it is 6, here it is 16, here it is 33, here it is 12, and it will assign the large square. So let's activate this one and square. So you can see the changes now. Fine. Again activate this. When I go for this option, what it will do, it will generate the square, the largest square on the basis of the row. So here 6 is largest, so it will have a large square, then 9, then in this case 20. So let's activate this and go for the shapes. Perfect. We can also have the count hits only one time the document. I can binarize this, that is only one time. If the code has appeared, it will give me the output 111. Again the original codes. Sigma, do you want the summation of these codes or not? Fine. Again I can click on this segment matrix. Click here, work-life balance. Just a minute. So such coded segments will appear. Okay, such coded segments will appear. Now close this. Again, I will click on this refresh and change this to the second method, proximity of the codes in the same document. Maximum distance is one paragraph, one text. So click on it, click OK, and you get the another results. If I want something more in the column, what I'll do, I will click here. Let's check. Is it generating? Refresh. Click OK. Yes, it is generating. Now I will get another set of results. Naturally, the number of coded segments will increase because now we are not looking for the intersection. Now we are looking for the proximity. Okay, this is a second method. All the options are available: square, circle. Third method. Again, click here. Occurrence of the codes in the same document. Click OK. And click on the numbers. Now it will give more coded segments. You can double click on it and just check, is it generating 42 coded segments? Let me check. So just a minute. Yeah, here it is generating. Fine. Again, maximize it. Now you can click here on the code map. Click OK. So I will explain this thing in the next video. So this was all about code relation matrix in MAXQDA. For more videos on MAXQDA, please subscribe to my channel. You can also refer my playlist in which I have uploaded many videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also join me on different social medias, link given in the description box.